Okay, so as you may have heard about computer development, we've technically had devices that are considered computers for thousands of years, right? Um, Maybe thousands of years. The Chinese invented the abacus, the earliest known tool for mathematical calculation. Essentially, it is just a calculator, right? Anyone know how to use an abacus? Like, actually used it before? No, I haven't either. I don't know really. I mean, I'm sure we could figure it out and sit down with it. But an abacus is supposed to be able to perform square and cube root functions and all the other standard operations: addition, subtraction, multiplication, division, the four standard operations. All with basically beads on in a frame, right? I mean, you could see in principle how it's supposed to work. I don't know. I've never used one before. I've had them. I've played with them when I was little, but never actually used one. And handle numbers all the way into the trillions. Um, and as they say, the upper beads represent numbers in fives. The lower beads represent numbers in ones. Beyond that, I couldn't tell you how to actually use the abacus. So the abacus, the earliest known calculating tool using beads. There are other devices, one back in 1830 called the analytical engine. So that's one of the first, what you could think of as more modern computers, still not like an electrical device, more mechanical, 1830 mechanical computer. 1944, a device called the Mark I by somebody named Howard Aiken, 5 calculations per second. What were we measuring just a little bit ago when we were talking about computer speed? What were we measuring in? Yeah, right? Like at the slowest, millions of operations per second. This one did 5 per second. So super low powered compared to what we have nowadays, of course. The first like actual computer, this guy here, the electronic numerical integrator and calculator, by two people named Eckert and Mauchly, 1946, so 2 years after the previous one that did 5 calculations per second. This one's working at 5,000 calculations per second. That's an order of magnitude 1,000 times bigger, right? So 10 to the 3 more powerful than the previous computer. So a significant improvement in processing speed. Here's a picture of it, at least a picture of part of it. Took up the entire floor of a building. And so the first fully electronic computer, though, that's a big thing. It worked by having these devices called vacuum tubes. You guys know about vacuum tubes because we use a vacuum tube in the X-ray room. It's just a different kind of vacuum tube. And these devices would either turn on or turn off, and those would be equivalent to the 0 and 1s that you would get as you may know, as binary computer instruction. These transistor vacuum tubes had either an on state or an off state, and they would often break. So it had 18,000 of them. And so you have a technician whose job is to go in and service the machine and replace those vacuum tubes. So he's shown here replacing one of 18,000 vacuum tubes. Okay, so then moving on historically, onto the next, the electronic, discrete, variable, automatic computer. Same people, 1949. The first stored program digital computer, using more complex math, and I'm just going to say more complex math. You guys don't know who Boolean and von Neumann are, but more complex math. Okay, then up to 1951, just a couple years later, the Univac, the Universal Automatic Computer, from IBM. You guys know about IBM. They're a huge company nowadays. It's the first mass-produced computer. So this is a picture of the IBM Univac. Again, still taking up an entire room, but able to be mass-produced. It wasn't just, built into the building. You could buy it and have it put into your building. But took up an entire wall and had an entire separate set of control consoles.